You can have one of those. All right, so sorry this video is late, guys, but I'm going to walk you through 41, 45, and 47. And I'm only doing 45A and 47A because for 47, if I do A, then you can do B, C, and D, no problem. And for 45, I'm only doing A because that's really the only one that I care about, if I'm being honest. And then B is like a challenge problem to see if you can think outside the box. So I'm looking at 41. It wants us to find functions f of x and g of x, so that way it can be given, the given function can be expressed as h of x is equal to f of g of x. And it's telling us that h of x is 3 over x minus 5. So when I'm looking at this function right here, 3 over x minus 5, I really need to think that this actually represents two functions in one. So I want to try to think of what those two functions are. So if you remember, when we're composing functions like f of g of x, we're putting them two together. So we always start with the bones of the outside function and then stick the inside function in there. So I'm trying to think of what the bones of f of x might look like. And see how it's 3 over x minus 5? Well, g of x has to be replace that x. So I'm going to say that my best guess, and there's multiple ways you could do this, but I'm going to say that the actual parent function f of x, the outside part is f of x equals 3 over x. And the reason why I say this is because if f of x is 3 over x, and then let's say I say g of x, and put g of x in a different color. G of x is x minus 5. Then it makes sense that f of g of x would be 3 over x minus 5, because remember, when I do that composition, I'm just replacing the x in the outside function with the inside function, which if in this case that would happen. You could have also said that f of x was 3 over x minus 5 and that g of x was just x. It would give you the exact same thing. But this is just a little bit better, more, it's a more complex answer, which makes it better. So that's all you had to do, is really kind of think of a way you could have two different functions that together make the function h of x. So now let's go move on to 45. 45 says let f of x be a linear function with form f of x equals ax plus b. And you might remember that y equals mx plus b, that's a linear function. So it's making a line where constants a are a and b. So we need to show that f of x is a linear function as well. So what I'm going to do is this is like your first proof that you're going to do. I'm just going to plug in f of x into f of x. So starting with the bones of the outside function, which is that f of x, I have a, and then I'm just going to put parentheses x plus b. And then now what I'm going to do is I'm going to put ax, oops, sorry, it's supposed to replace a parentheses x plus b. And now I'm going to put ax plus b inside of there because this is f of x, but I'm doing f of x. So I'm going to put ax plus b in there. And then to prove that this is a linear function, I need to simplify it to make sure it's not a quadratic. So I'm going to distribute the a in. And when I do that, I get a squared x plus ab plus b. And so what this shows me is that even though I have the square here, this is just a number, right? A squared is the constant. It's the coefficient, but it's not a variable. It's just like, obviously here it's variable, but it represents an actual number. So it could be 2. So this could just be 4x plus, again, if we're looking at a being 2, then let's say b is 3. Then it's plus 2 times 3 plus 3. And if I simplified that, again, this is a little bit abstract, it just gives me a number here and a number here, because AB plus B, that is going to equal a number. It's going to be a constant. It's not going to have an X in it anywhere. So this is actually still a linear function. And we're going to write a sentence explaining that, just so it's not like, oh yeah, it's just a function. So this is still a function because A and B represent constants. And whenever you add two constants, you get a constant, right? It's not saying that 2 plus 2 is all of a sudden going to equal y. That's not going to happen for us. 2 plus 2 is is 4. It's going to be another number. So that's how you show that it's still a linear function. Okay, and then now the hard one. So a car leaves Seattle heading east, and the speed of the car in miles per hour after m minutes is given by the function c of m equals 70 m squared over 10 plus m squared. So it's important to recognize that in this formula, m again represents the minutes. And this formula is calculating the speed of the car in miles per hour after m minutes. So we need to find the function m equals f of s that converts s into minutes. We need to write out the new function c of f of s. So we need to try to figure out how I can convert minutes into seconds. So if you think about it, we know that there are 60 seconds in 1 minute, right? So how could you write that as a conversion? This is actually what Integrated 1's working on right now, is those conversion factors. So again, S representing seconds. That's what it says. Yeah, S represents seconds. So how can I convert the seconds into minutes? And so I know that if I'm given seconds, then that's, I wanted to cancel seconds, right? To get minutes, I put 1 minute over 60 seconds, right? You guys probably did this in physics, and that would cancel out my seconds, and that would give me minutes. So this actually right here, this is what we are going to use as our conversion factor. We're going to use this as our function. So looking at my function, f of s is equal to s, so lost my spot, s over 60. Okay, and this again converts the seconds into minutes, because let's say I had 120 seconds. Well, then 120 divided by 60 is 2. So that's going to give me 2 minutes. So this checks out right here. So using that, now I'm going to show what c of f of s is. I'm going to use my equation tool because we are dealing with fractions. So remember, c of f of s, I'm going to replace any part. So let's start with c of m. So it's c of f of s. And so that's equal to, I start out with my parent function, 70. And then up here also is that parentheses squared over 10 plus parentheses squared. So in each of these m's, I'm going to replace it with my new function, f of s. And so f of s, remember we just said was s over 60. Not 69. It always makes an appearance. All right, and then s over 60. Probably put the right amount of variables. Okay, and so I have my function. I wrote out my formula for the new function, c of f of s. But once we take this step forward further and say, what does this even calculate? Well, let's think about it. The inside function converts from seconds to minutes. And then the outside function determines the mile per hour in minutes. So if I put those two concepts together, then really what this function is calculating is a speed of a car after s seconds. So see how it just kind of changed it. So the original function gave the speed of a car after m minutes. Well, by putting that conversion, s over 60 into the middle, now we're finding the speed of the car after s seconds. So we're breaking it down even further. And so we're going to write that. This function gives the speed of the car after s seconds. And that's all it does. So that's why composition of functions could be easy, because yeah, it'd be nice to find the speed of the car in miles per hour after minutes, but sometimes we just want to look at it after a few seconds. So that's how you do it. All right, again, any questions, please feel free to reach out to me. You guys are doing good.